Hi, my name's Nick and I'm an engineer at Marmalade. In this video we're going to build a basic Hello World application, run it on desktop and then run it on a Windows Phone 8 device. I've already set up my desktop machine with the Windows Phone 8 SDK, the Marmalade SDK and a copy of Visual Studio 2010. We're going to create a folder for our project, so I'm going to just make Hello World here. Open that up and inside I'll create a Marmalade project file. So this is basically a text file. helloworld.mkb. I could use the launchpad to create a project, but what I'm going to do here is basically go from scratch just to show you the different formats and how everything fits together. And if I open that up with a text editor, so I'm going to use Notepad++. Basically, the project files just contain things like deploy options, build options, source files, assets to deploy, and then it'll create an actual Visual Studio or Xcode project out of this. So if I do files, we're going to have one source file which is helloworld.cpp, and I'm also going to use a sub-project called IWGX. So sub-projects are basically a way of including other MKB files within an app to sort of spread the code around, and IWGX is some middleware for doing 2D and 3D rendering. So in this case all we're going to use it for is for printing text to the screen. So I'll save that, close it down. And then also I'm going to create our source code. So helloworld.cpp. And when I installed Marmalade, I set Visual Studio 2010 Express as my default editor. So if I double click on an MKB, it should launch that IDE for me. Get rid of that. And over on the left here, you can see basically this is a pretty standard Visual Studio project. So I've got the source file here that I included. I've got my project file underneath, which I can edit in the editor. And then also here we have the Marmalade abstraction layer. So you can see things like accelerometer, camera, clipboard, compass, and so on. Standard libraries, that kind of thing. At the top here, you've got Marmalade Studio. So this has got IWGX that we included, plus some dependencies of it. So I'm going to add some source code. Nothing too complicated. So first thing I'm going to do is include the IWGX header. We've got code completion. Have a main function as our entry point. And I'm going to initialize IWGX. So basically this just does basic kind of setup stuff. On some devices like Android, it might set up some things to do with state caching later on. And then I'm going to put IWGX terminate at the end. So it's nice to clear up all of our assets when we're finished with them. Return a value. I'm going to set a clear color here. So this is just the color the screen gets cleared to. It's a regular RGB number, so I'm going to make it blue. And I'm going to have some alpha so I can actually see it. And then we'll have a while loop where we do our rendering. So a Marmalade specific thing here, I'm going to use S3 device check quit request. So basically this just checks whether anything's asked the app to close. And essentially things like, for example, if the user's pressed a back button to close the app, or if the OS has decided to close the app because it's out of memory, this will just respond nicely to that kind of thing and make sure that the app closes down properly. Should spell that properly. And then here we're going to just clear the buffer. So IWGX clear, we'll display our blue color that we set earlier. Draw some text. Add a position on the screen. And then if you're used to GL rendering, basically we're going to have some similar functions here. So I've got IWGX flush, which will push all our drawing commands to the buffer, and then IWGX swap buffers, which swaps the back and front buffers to display to the screen. And then finally, another little Marmalade thing, we've got S3 device yield. So basically This just gives the OS a little bit of time to do anything it might need to. On a lot of platforms, it doesn't really do a huge amount, but on some platforms, it lets things like callbacks run properly. It gives the OS time to do background updates and that kind of thing. So it's good to call that once every update just to make sure that everything runs smoothly on the phone. I'll just save that. So at this point, I'm going to run it in the simulator. I can just pick x86 debug, say, hit build and run. And this will build an x86 binary, launch the Marmalade simulator for us. So the simulator just simulates different kind of devices for us. We can go to configuration, we can play around with pretend accelerometer, we can set things like fake locations so the location APIs work, and so on. A main thing you might want to do is just go to Surface, and you can play around with different resolutions, so set it up to match your iPhone, BlackBerry, Windows Phone device sizes. And there you can see our hello world there, nothing too exciting. So one thing we have to do for Windows Phone 8 is it has a dependency that you can only use precompiled shaders, and also Windows Phone 8 only supports GLES 2. So basically you have to use shaders and you have to precompile them. So most devices will actually just do shader compilation at runtime, but Windows 8 won't. So in order to help out here, we've got a little setting where we can force it to pre-build the shaders for us. So if you're rebuilding an existing game, you'd probably want to do this to get your app running on Windows Phone. So I'll just do precompile shader binaries equals 1. And basically, when I run the desktop build, when I run it, then it'll build the shader binaries for me and spit them out to some binary files. And then when we run it on device, it'll automatically load those, so you won't notice that any of this has happened, but it's a little precompile step that you have to do. So if I save that, run it again, and then if I open up the folder here, you'll see it's built a data RAM folder, and in here it's spat out the shader binaries into this folder. So as I said, you don't really need to know anything about how that works. You don't have to set those assets to be picked up yourself. It'll all be automatic, but it's just worth knowing that for Windows Phone 8, you pretty much always have to do this. If you're using GLES 1, you wouldn't need to, but the Windows Phone 8 devices don't support GLES 1 at the moment. In fact, an interesting thing with Marmalade is that Windows Phone only really supports DirectX, so we're actually doing work under the hood to make all your GL code run on Windows Phone 8, and this is kind of one of the only ways you can really do that with Windows Phone at the moment. So I'll just shut this down. So to get it running on device, as I said before, we have to use the Visual Studio 2012 SDK that came with the Windows Phone 8. So if I go here now to my MKB, just going to shut that down. If I right click, I can now pick the 2012 Express Windows Phone option here. So it's just going to open the same project again, but this time as a Visual Studio 2012 for Windows Phone project. Give it a second to load up. So you'll see pretty much the same thing here, except with Microsoft's new IDE. And this is actually the first time I've run this, so it might take a little minute to do a bit of installation. So over on the right here, same kind of stuff as before. We've got our source file, our MKB, and so on. To put it on Windows Phone, all I've had to do is plug in my Windows Phone, set the phone up as one of my registered devices, which you can see in the other video, and then I just need to make sure that the configuration is set. So I've got device, I'll do a debug release, I guess, and ARM for the ARM architecture on the device, and then basically that's it. You can hit run and go. One thing to note with this that's quite interesting is because we're using the native toolchain for Windows Phone 8, we can actually do on-device debugging straight from Visual Studio. So I can, for example, drop breakpoints straight into my code here and step through them on the phone. And at the bottom here you can see it's just basically powering up the connection to the device and pushing the ZAP package straight across. And there you go, I can just use step over like any normal Visual Studio project, but running directly on device. And there we have our first Marmalade project running on a Windows Phone 8 device.